Welcome back to section 5.5.2, quadratic function transformation. In this section, we're going to focus on domain and range, and it's going to be the same rules as shown for the previous section, absolute value function transformation. To review, domain is always starting with the left x value from the graph, if you have it, to the right x value. And then for the range, you're going to start from the bottom y value of the graph and then end with the top y value of the graph. So what we're going to start off is you're going to have the equation with its corresponding graphs. Once we understand the rules on identifying domain and range, then we're going to apply the same rules to given equation and identify the domain and range without using the graphs. So let's take a look at the first two sets we have here. So the direction is identify the domain and range for each given equation. So now here on example 1, we have f of x equals the absolute value of x plus 2 and then minus 3. And then if you compare it to example 2, g of x equals the square of x plus 2 and then minus 3. So comparing between example 1 and example 2 equation and the graphs, the equation has different forms. The equation 1 has absolute value form, while equation 2 have quadratic form. And if you look closely at the graphs, for absolute value, it's a V-shaped graph, just like this, whereas the quadratic graph is a U-shaped graph. So what we're going to do here is see what is the difference between an absolute value to the quadratic when it has same numbers and the same position, just different forms of the equations and different form of the graph. So looking at absolute value, example 1. Now when we're doing domain, what we want to do is first draw out the arrows for the left side and the right side. So if we were to draw the arrows, it would look something like this. So this will help indicate my domain. Now if I were to analyze the arrows, and if you look closely at the ends of the graph on both sides, you see how they have arrows. It means that it's a continuous graph. It goes on forever. So for domain, we're always going to start with the left side. Since the left side is going on forever, and if you look closely, the left side tend to have negative numbers. Most of the time, it will be negative numbers. So in this case, since it's going to the left side forever, then we'll be using the symbol negative infinity. And then for the right side, or the right x value, you can see that it's mostly positive numbers. But again, it has the arrow at the end. That means it goes on forever. So if it goes on forever towards the right, then you're going to end up with infinity. So our domain is going to be written as this. And again, whenever you're working with infinities, you're going to be using parentheses for your domain in interval notation. So be very careful, because sometimes you're going to use parentheses and sometimes you're going to use brackets. Make sure you know when to use them specifically at which time. All right, now moving on, we just finished domain, so we're going to move on to identifying range. So identifying range, we're going to do the same thing, which is draw the arrows, but also mark, in this case, the bottom y value. So here, I drew my arrows pointing up, because the reason I'm drawing pointing up is if you look at the sides of the graph, you see that both sides are going diagonally. So on the left side of the graph, you see that the graph is going in two directions, left and up. On the right side of the graph, it's going in two directions, right and up. So that's why we see two sets of arrows. In addition, I circle the bottom of the bottom y value of the graph. And the reason I also included a number is that you can see how that number helps out with the range. So first off is the bottom y value. So we're going to start at the bottom of the graph, which is right here where I circle. So the bottom y value is at -3. So since it's at -3, it's going to include a bracket, which you have here. So this is a range. Now, since you have the arrows going upward forever, and both sides are going upward forever, so that means that it's going to be having the same top y value. So since it's going upward forever, that means that we're going to be using infinity, because as we can see on the y-axis, if you were to go upward, most of the time we're going to have positive numbers. So if it's going upward forever, we're going to be having infinity, or also known as positive infinity. So that's why we have it in our range. So this is going to be our bottom y value, which is, as you can see here. But if you look closely, this is a bracket. So since you see the graph is at -3, that means that -3 is included into the range, or is included into the graph, or included into the solution. So that's why we have a bracket. Now for parenthesis on infinity is because we cannot reach infinity, or we won't be at infinity, because whatever number you find, you're always going to find a higher number. So you will never be able to reach it because it's going to keep going forever. All right, so let's move on to example 2. This equation and this graph. Now I've already do the same process for identifying domain. Again, I would do the same thing as drawing the arrows as I did here, like so. So I'm drawing the arrows to indicate which way it's going and going towards where. So if I closely analyze the arrows, so on the left side, and if you look closely at the both ends of the graph, it has arrows, meaning going on forever. So going back to the left side, if the left side, which is again has mostly negative numbers, and it goes on forever, that means that it goes towards negative infinity. Whereas on the right side, which has mostly positive numbers, if it goes on forever towards the right side, then we're going to end with infinity or positive infinity, and the domain is going to be written like this. So parenthesis, negative infinity, comma, infinity or positive infinity, and then close parenthesis. Now, moving on to range, I'm going to do the same thing as before. What I'm going to do is draw my arrows for going upward, and then highlight the bottom, or circle the bottom y value like this. So again, we have two sets of arrows on the left side and on the right side. Again, if you look closely at the blue graph, so on the left side, you see how it's not going straight up nor going straight left, it's going diagonally, meaning that it goes into two directions, left and up. And then on the right side of the graph, again, you don't see it directly going upward or going directly right. You see it's slanted or diagonal, meaning two directions. So that's why we have right and up. Now, for the range, we're going to start with the bottom y value. So the bottom of the graph is here. And as you can see, I circled it, including the number. So if you look closely, the graph is right at -3. So that means that -3 is included into the graph, or it's included in the solution. So here's the range, and as you can see, we have included a bracket on the -3 because that number, as you can see, if the at the graph, it's right at -3, so that means that -3 is included, hence we have bracket. Now for the top y value, you see how these two arrows are going in the same direction. They're going upward, so they're going to be going to the same top y value. Since the graph is going upward forever, and upward on the y-axis has positive numbers, so going upward means going towards infinity or positive infinity, which is why we end the range with infinity and then close parenthesis. So comparing the two sets of example 1 and example 2, the two sets equations, the two sets graphs, and then the two sets domain and range, they just have different form, but at the end, you see how the domain and range are basically the same. Because if you look at the equation and the graph, they're basically having the same numbers with the same position, and the graphs are basically going in the same directions. It's just different forms. Essentially, at the end for domain and range, it's going to be the same. If they have the same numbers with the same sign, then again, it's going to be the same domain and range. Moving on to example 3. Now, example 3 is h of x equal the square of negative of x minus 3 and then plus 1. So what's different with example 3 is that we have a negative inside the outer parenthesis. So that means it's going to be a reflection across the y-axis. So let's see how a reflection plays in terms of domain and range compared to example 1 and 2. So just like before, if you're given a graph, I will usually draw the arrows to help indicate in what direction they're going. So since we're starting with domain, that means that we're going to focus on the left and right. So when I draw my arrows, it's going to look like this. So I have my left arrow and my right arrow. In the end, when you're identifying domain and range, if you look closely at the ends of the graph, it has arrows. So that means it goes on forever. So even though if we were to compare and analyze the left side, even though we have positive numbers, if we go towards the left side continuously, most of the numbers that's on the left side is negative numbers. So if we go continuously to the left, that means that it's going to go towards negative infinity. Because like I said before, if it goes continuously, it means it goes on forever to the left, therefore negative infinity. So we're going to start with negative infinity for the domain. And then on the right side, it goes on forever towards the right. And as stated before, right side usually have positive number. So if it goes on forever to the right, then it goes to positive infinity or simply infinity. So our domain will look like this. Parenthesis or open parenthesis, negative infinity, comma, close parenthesis, infinity, and then close parenthesis. So after identifying domain, then let's focus on the range. Now range is the bottom y value and the top y value. So for the bottom here, which is located right here, I'm going to circle that. In addition, I'm going to draw my arrows going upward because you see the two ends of the graph is going upward. So when I draw my arrows in my circle, it's going to look like this. And same thing as what I did for the previous example, I also circle including the number. Because if you look closely at the graph, you see how it's lining up with the 1. So it's right at the 1, meaning that the 1 is included into the graph and included into the solution. So since it's included into the graph and included to the solution, that means that when we start off with the bottom y value, we're going to start off with 1 with a bracket, as shown right here. So there's a bracket on the 1. Now for the top y value, we see that it's going upward forever for both of these arrows. So they're going to go to the same top y value regardless if you're on the left or on the right side. So since it's going upward forever, and then upward has mostly positive numbers, so that means going forever upward is going to infinity or positive infinity, which is why we're going to end the range with infinity and then close parenthesis. So my range is bracket or open bracket 1, because that's where the graph lines up at the bottom, or I should say the bottom of the graph lines up with the 1, then comma, infinity, and then close parenthesis. Now moving on to example 4, we have k of x. Well, before that, if we were to go back and analyze example 2 with the domain and range, and then compare it to example 1 and 2, you'll see that the domain and range is pretty much the same format. So if there's a reflection across the y-axis with the negative inside the outer parenthesis, then there's no difference in the format for domain and range. Now, let's take a look at example 4. So for example 4, we have k of x equals the negative of the square of x plus 1 and then plus 4. So since we have a negative sign that is outside the parenthesis, that means that it's going to be a reflection across the x-axis. As you can see in the graph, it flipped over the x-axis. So let's see how it plays in terms of domain and range. So for domain, again, is where we're going to draw the left arrow and the right arrow. So when you draw it, it's going to look like something like this. So let's analyze the left and right arrow. And in addition, if you look at the ends of the graph, of the blue graph, you see it has arrows, meaning it goes on forever. So for domain, we're going to start with the left x value. So the left side, if it goes on forever towards the left, so left side tend to have negative numbers. So if it goes on forever to the left, then we're going to start with negative infinity. And then for the right side, since it's going forever to the right, and right side has mostly positive numbers, going forever to the right means that we're going to end with infinity or positive infinity. So when we write out our domain, we're going to start with negative infinity and end with positive infinity, or just infinity. And it'll look like this. So we're going to start with open parenthesis. The left x value is the negative infinity, comma, the right x value is infinity, and then close parenthesis. So that's what our domain is going to look like. So far, pretty much the same as all the other domains, for example 1, 2, and 3. Now for the range, we're going to be drawing our circle to highlight the bottom or the top y value and then draw our arrows. So since the graph is flipped or reflected across the x-axis, so it's basically facing the opposite direction. So my bottom y value, since it's going downward, it's going to have the arrows. And then we actually have a top y value where we're going to circle. So when we do that, it's going to look like this. So again, since the graph is flipped across the x-axis, you see how it's going downward forever. And then we actually do have a top where I circle, including the number. So for the range, if we start at the bottom y value, which is right here, so this is the bottom. So since it's going downward forever, that means going downward forever is the negative numbers. So going forever downward means negative infinity. So we're going to start with negative infinity for our range. And then for our top y value, which is right here that I circle, if you look closely, the top of the graph lines up with the 4. So it's at the 4. That means that the 4 is included into the graph and it's included into the solution. So we're going to end with the 4 and with a bracket on the 4. So when you write out your range, it's going to look like this. So open parenthesis, negative infinity, comma, 4, and then close bracket. So like I said before, range starts at the bottom y value. So here's the bottom of the graph. Since it's going downward, as I indicated with my arrows, it's going downward forever, we're going to start at negative infinity for bottom y value. And then if you look at the top of the graph, it actually ends with a number, in this case the 4. That's why I wrote the 4 here with a closed bracket, because the graph is at the 4, or it lines up with the 4. So in this case, since it's a negative outside the parenthesis, meaning reflected across the x-axis, the only thing that was different was the range. As you can see, comparing between example 4 and example 3, our range is in a different format. So be very careful if it's reflected across the x-axis. In terms of domains, it's pretty much the same. It's just for range is going to be different format. So be careful when it's reflected across the x-axis or when you have a negative sign that's outside the parenthesis. All right. So for the analyze, let's sum up on what we know is about the domain, the range for each type of equation, each type of quadratic equation. So the first part, we notice that the domain was the same for every type of quadratic equation. If it was reflected across the y-axis reflected across the x-axis, or there was no reflection whatsoever, the domain was always the same, meaning that it starts with open parenthesis, negative infinity, comma, infinity or positive infinity, and then close parenthesis. Now, let's talk about when it was reflected across the y-axis. So if it was reflected across the y-axis, the only thing different was the range was the same format. Well, I won't say the only difference. It says the range was the same format as non-reflected equation, which are two examples here. Just like so, you start with open bracket, a number, comma, infinity, and then parenthesis. So same format as the non-reflected equations. Now, when it was reflected across the x-axis, the range was different. So again, stated here, reflected across x-axis, the range was a different format where we start with open parenthesis and then negative infinity and then comma 83, as given in an example, ended with a closed bracket. So as I stated at the beginning of this video, we're going to be using parentheses and brackets. You just got to know when to use them exactly and where to use them. So be very careful when you write out domain and range, because you want to be able to give the accurate domain and range. If you use the parenthesis or bracket incorrectly, then you're giving me incorrect domain or incorrect range. So moving on to the equations that you see below, you're just given the equations and you're asked to identify the domain and range. So now you actually have to do all of this without the assistance of a graph. But like I said before, if you follow the same patterns, then the same patterns from where we wrote for the analyze, then it's going to be easy to apply them without actually using the graph. So for domain, if I go back to what I said in the analyze part, domain was the same for every type of quadratic equation, which was this. So then for domain, I just simply have to write if you have a equation like this, then my domain will be from negative infinity to infinity with parentheses, like so. Now, for our range, since this is not reflected, that means that it's going to be similar to the reflected across the y-axis. The range was the same format as non-reflected equation, so our range is going to look something like this. Now, where do we get the number? Well, if you have the graph, you can see where the number comes from. But as I stated for absolute value, this number that's in the back, the one that's behind the square and behind the parenthesis, it's the same principle, same rule as if it was behind the absolute value. This number will help with the range. So that means that this is where we're going to start. So minus 26, meaning that we're going to start at negative 26, and then we're going to end with infinity. So as you can see, we started with negative 26, which is the same as this number, minus 26, and we're going to end it with infinity. But keep in mind, I have parentheses on infinity, and I have a bracket on the number. But keep in mind that in some cases, some equations, or some certain types of equation, sometimes we're going to be using parentheses on numbers. You just got to be careful on what type of equation that you have or what type of graph you have. Now moving on to example 6, we have m of x equal the negative of the square of x plus 17 and then plus 45. So since we have a negative sign that's outside the outer parenthesis, is a reflected across the x-axis, so that means that the range is going to be different. For domain, as we stated up here, it's the same for every type of quadratic equation, regardless if it's not reflected, reflected across the x-axis, reflected across the y-axis, domain is always the same. So, as expected, like example 5, this will be the same domain for example 6, as shown here. Now for the range, like I said before, it's going to be a different format, meaning that we would start at open parenthesis and we're going to have negative infinity, comma, and then the number that we're going to end with will be with this number that's behind the parenthesis or behind the square. So that means that we're going to end with 45 with a closed bracket. So our range is going to look like this. Starting with parenthesis, negative infinity, comma, 45. Since we have plus 45 in the back of the equation, we're going to have positive 45 in the range with a closed bracket. Now moving on to example 7, we have g of x equals the square of negative of x minus 21. So, and in addition, we have the minus 37 at the very end. So in this case, we do have a negative inside the outer parenthesis. So negative inside the outer parenthesis means reflected across the right axis. So it says that the range was the same format as non-reflected equation. So that means that the domain and range is going to be the same format as example 5. So as I stated before, domain is the same for all types of equations. So domain is going to be negative infinity to infinity, like this, with parentheses. Now for the range, like I said before, it's going to be the same format as such as example 5. So we're going to start at the number, more specifically this number. So it's behind the parenthesis, behind the square. So since it's minus 37, we're going to start at negative 37 with a bracket and end with infinity or positive infinity with parentheses. So again, start with open bracket, negative 37 because of this minus 37 here, comma, infinity, and then close parenthesis. Now for example 8, we have k of x equals the negative of the square of x minus 6 and then minus 74. So in this case, we do have a negative outside the outer parenthesis. So it's going to be reflected across the x-axis. So it's going to be similar to example 6. Now for the domain, pretty much the same as any other quadratic equation. It's going to be negative infinity to infinity with parentheses, like so. Now for the range, it's going to be in the same format as what we have in the analyzed part and in example 6. So we're going to start off with open parenthesis and negative infinity, but we're going to end off with the number that we have here in the given equation. Since it's minus 74, that means we're going to end with negative 74 and close bracket as shown here. So like I say, start with open parenthesis and then negative infinity, comma, and then end with negative 74 close bracket. So like I stated before, be very careful on when you're analyzing the equation. Take a look if you have negative signs inside or outside, and make sure you follow the rules as what we wrote for the analyzed part.